I want you to sort of, how many folk got the lab to work? Okay, a fair few. I mean, what I wanted you to have is this concept of, if this is my window, which it is, with all the various bits and pieces in there, I drop into the code behind the window, which does the editing, and that all that does is it asks the business object to do stuff and provides the user interface. So the idea is that, and this is the key bit for me, this method here, start account edit, is really important to me. And he'll have a friend called, well, will he have a friend called end account edit? Maybe he won't. But this is the one which basically says, I'm going to make a note of which is the active account we're editing. I'm going to fetch his name, and I'm going to put it on the name text box. Then I'm going to fetch his account number, and I'm going to put that on the account number text box. Then I'm going to get his balance, which is a number, and I'll convert it into a string, and I'll put that on the editing surface as well. So all this thing does is it provides a surface on which you can work with the account. And as soon as I do something which tries to touch the account, and you'll see as if I hit, say, pay in funds, here we go. As soon as I try and hit pay in funds, then I call straight through to the account I'm presently working on and see if it likes it. If the business object likes it, then I can put I can basically update the text on the display to say, yep, he's taken some money out, his balance has now changed. If it doesn't like it, then I'm going to give a message box up that says, you couldn't do this. So I want you to think in terms of the account editing process being a thin shim, a thin layer, which is the page we're working on, and then behind that, a link to the business object we're actually working with. Does that make sense? So at no point should any of the code in here do things like fiddle with the balance of the bank account directly. It's perfectly okay to ask the bank account, hey, is it all right if I try and pay 50 quid in? And the account goes, yeah, that's fine. If we go, hey, is it okay if I try and pay in minus 50 quid in, what should happen? Shall we try? I mean, it might work. I'm not sure if this one works. If I right click on here and go to definition, let's take a look. Yeah, it doesn't like it if you try and pay in less than 0. So if I run the program and put a breakpoint here, we can run through the entire workflow. So I've got Rob, there he is. Let's try and pay in minus 50. Okay, hit pay in. First thing it does is it asks the account, hey, are you happy with this? So we step into the code. Minus 50 is less than 0. We can't pay in negative amounts. Our account won't let us. Straight through. Return false. So the attempt to pay in the cash has failed, which means that this part of the else part of the test runs. And so we put our message up saying we couldn't pay this amount in. It was invalid. And the one piece of glue I'm not showing you, which I'll show you in a second, so that up comes the message and we don't like that. And the one piece of glue that I'm not showing you, if I just keep on looking at the code, if I go a bit further down, I've got, this is my pay in button click event handler, and this is actually the bit that takes the text out of the text box, converts it into a number, and then calls pay in funds to dispatch that. Now, the reason I've done that way, well, okay, why haven't I put all that in one big method? Why have I got a pay in funds method and a click event handler as two separate things? Any ideas why? Yeah? So if you delete the button, you don't lose all your work. That's a good thought. I mean, the reason why I'm heading this way, I haven't done a very good job actually. I should have another method in the way. The reason why I've done it is that if you've ever used a Windows application, and Visual Studio is a good example, if I hit any one of these behaviors, then you'll find that I can pick them off the menu. I can use a hotkey. There might even be a button I can press that does that. I might have 3 different ways of triggering that behaviour. Pick it off a menu, press the button, hit the hotkey combination, okay? There might be 3 ways I can do this. In that case, I want all 3 of those actions to feed through into my method that does the work. So if I separate off the bit that does the heavy lifting from the bit that deals with the event, then maybe, just maybe, that will make it easier for me to deal with the fact that we might have, if the bank cashiers are very busy, they want to keep their hands on the keyboard, not go off and find the mouse. We want to say that Control-Alt-P lets you pay in funds, say. They might like that, so I might have several different ways of triggering the pay in funds method. So in that situation, it's worth bringing it out as a separate method and calling through. Does that make sense? This is all, but we've gone beyond this is how a for loop works kind of approach to programming, and we're now at the level of this is how you make good quality code, which is kind of nice because it means that I can show you lots of coding tricks in a good strong context, and it plays well at interviews and when getting a job, because this is the stuff that you should be thinking about. But the key message from this, and we'll see it time and time again, is that the user interface is a tiny, thin layer on top of your business objects that do the actual worrying about the data. In other words, it would be a really bad plan if my user environment, my front end, was checking to see if the balance was wrong. I shouldn't have code like this. I'll show you the code I shouldn't have. I should not have code like this if amount is less than 0. Message box dot what? Why is that wrong? You might think that's a good thing to do. Why is it wrong? Any ideas? Whose job it is? Whose job is it to decide whether or not an amount is valid to pay in? It's not the user display's job, is it? Because it doesn't know about how banks work. We're not allowed in the display to make decisions like, I don't like this amount value. We're not allowed to do that. It's called division of purpose. It's not the job of the UI to decide if the business data is valid. The only person that can tell me if a particular action is valid or not is the business object. So I'm not allowed to do this. You might think, well, hey, I can speed things up by putting a test in there rather than calling all the way through to pay in funds and getting the answer all the way back. You might think that. It's not a really good idea, though, because what it means is that I've now got 2 places where decisions about account quality are being taken. Okay? And I don't like that. I want one place, I want one oracle, I want one mountain, I want one set of tablets, one set of commandments, no other ones. So don't do that. Don't put any kind of business behavior inside your user interface because it's not where it should live. If I make the web-based version of this, or I make a server-based version or whatnot, I don't want to have different decisions happening in different parts of the system because it's very, very bad for managing what's happening. Does that make sense? Okay? What you'll be doing in the lab this week is building out the account behaviors a little bit. There's essentially two deliverables. The first one is I want you to add handling of the age of the bank customer and their income per year, and modify the way that the account works to improve the business process on those 2 things. And then we have a look at making fake names, which is a hilarious thing to do. And that's all quite nice. It's up there. Go and have a look. It's all good to play with. So what I want to do now is go back to what we're actually supposed to be doing today, which is static members and design. I'm trying to get you folks thinking what static actually means. And here we go. This is the first static member that we ever did see. We saw it on the first day of programming, and we saw the word static, and I pretty much told you ignore this. don't worry. The only reason why I want you to worry about static is if you don't type it in, it doesn't work when the program runs. Now I want to really bottom out what static means and, better yet, give you a context in which it's a good idea to use it. So we're going to learn about static and when it's a good idea. Everyone okay with that? Fantastic. Static means part of the class. Have I mentioned planet Jupiter in this context? So storm of apathy. Do you folks remember radios like old school? When I go downstairs in the morning and turn our radio on, it takes 15 seconds to fire up, makes a Wi-Fi connection, finds that because there's a Windows 10 update going on at the same time, there's no bandwidth and promptly crashes. So I basically hear about 3 words and it tips over. So then I turn the microwave on to make me porridge and it tips over again because the Wi-Fi breaks. So my radio is effectively useless. In the good old days, my parents had a radio full of transistors. You turn it on and Radio 4 would come out, just like that. But the thing about that radio, if you turned it off the channel, you hear this hissing noise. You heard that on old radios? Detune it and you hear this static noise, okay? That's always there. There's static in the universe ever since the Big Bang. What you're hearing is echoes of the Big Bang, that crackling noise. And the planet Jupiter is interesting because of all the objects in the solar system, it puts out more radio frequency energy than any other planet around. So if you point your radio at Jupiter, you get tons of static. What on earth has that got to do with programming? Okay, static means it's always there. Static means it's never not there. Static means I can refer to a method called main in a class called test, and I can be absolutely sure that main will be there when I want to use it. Now, members of an object only exist if we have an object to put them in. So, an account balance only exists when we've got the account, right? But the main method and all these static chums exist all the time. They're like the planet Jupiter. They're like the crackle on the radio. They're never going anywhere. They're actually there right from the start when your program runs. Okay? So every year in the exam, I set a question about static. What does static mean? And one of the answers is always cannot be changed. And I reckon about a third of the people say, yeah, it means it can't be changed. Woohoo! Give me my marks, please. No. Please don't fall into that sort of... If you want to make a thing that can't be changed, look at const. Const means I am constant. But static doesn't mean I can't be changed. It means I'm always there. I'm never not there. I'm part of the class. When the class is loaded, all the static objects are created at that point. So my program starts running. The test class is loaded because that contains a static method. At that point, the method comes into existence. It's already there. So that means I can call it straight away. I can illustrate this by showing you some code. Not this code. Let's make a new project, which we'll call static demo. And we'll hit OK. And yeah, we'll save all those guys. I don't care what happened there. It's fine. So here's my class called program. I can put an integer in there called look at me. There you go. Fine. All right. What happens if in here I go, well, let's try it. Look at me equals 0. What's going to happen? Red line. Don't like it. What does that mean? Why is it saying that?
It can't find look at me.
It can't find look at me. Why can't it find look at me? People's, I'm sorry, it's 5:30. I'm asking you a question. I do apologise. It's just the way it is. Why can't it find look at me? It's there. Look, I can see it. There it is. Ooh. Because I haven't got a program instance. If I do this, see if it likes this. program P equals new program, make me a program, and I go P dot look at me, it likes that a bit. Okay, let's give it a number, why not? Okay, it likes that a bit. So there you go. P dot look at me, it likes that. You can find it there, but it can't find it there. What's going on? This one here is a member of an instance of the program class. That instance is being referred to by a variable with the rather strange name of P, which is fine. Okay? So this look at me has an instance it's attached to, right? This look at me doesn't. It's part of a method which is static. And static methods, when do they exist? When does a static method exist? Always there. Whereas, so this guy here, static. Okay, this guy here only exists. Oh, go away. Where do you come from? If I do this right, I can confuse the entire class. This only exists when we make an instance. Because this thing's always there, because it's static, the compiler won't let it touch things that are not static. So the problem here is that, yeah, I can't touch you because you're not available in the context in which this method will run. Now, if you understand that, you've got it. How many folk have got that? The rest of you are going, oh, it's Friday night, so I want to go, but this is Monday. Crack, it's Monday. What a week. A little bit of wishful thinking there. Static means it's always there, correct? This thing here has to exist inside an instance of the class. So if I make a class instance, I can pick it up. But the compiler says, okay, this thing's always there, this thing isn't always there. So this thing can't touch that because it might not be there. The best thing is probably to stare at it for a while until it makes sense. When a static method runs, nothing else has to exist. So all it can touch is other static things. I could do this. Maybe this will help. Static int, static look at me. Okay, this guy's a member of the class. He's in the same club as main. So in here I can go static look at me equals 99, and the compiler goes, ooh, I love you for that, that's fine. Does that help? This exists all the time, just like main. This guy doesn't. So this guy, we make a new class and grab hold of it. This guy, it's absolutely fine to refer to that because he's there as well. I'm trying to think of an analogy that works. And all I can think of at the moment is if you're in the room and the other guy's in the room, you can talk to each other, but if he isn't, you can't. That doesn't really work, so we'll move on from that, okay? Think about the situation the compiler is in. When it sees the method is static, it means all you can touch is things that are already there. Anything we have to make an instance of to get hold of, then can't touch that, which is almost a song. So, I'll come back to that let's go forward by thinking about intent. Why on earth we do this? We make classes using new. We're quite good at this. The pay in funds method can't be static because it's part of the account class and it pays in funds, okay? The first thing pay in funds would want to do is touch the balance, and the balance exists for every single class, and therefore pay in funds can't be static, correct? Stick with me, I'll get there, I'll get the whole class. At the end of the day, you'll understand it, or you'll just nod to make me shut up, one of the two. I can't, either is a win as far as I'm concerned. I get paid either way, all right? So we can't make pay in funds static because it's part of a particular instance, wanting to work on a particular balance value. And that's sensible. I like that. But sometimes we want methods that are static to be part of our object. Now, the friendly bank has a fairly friendly policy with regard to its customers. It wants them to be rich and responsible, okay? Nobody under... How old are you lot? 12. Right, I'll take that. No one under 12 is allowed to have a bank account or whatever, okay? So we don't want people that might spend all their money, and we don't want people who are poor, because banks don't want to have anything to do with poor people or bad news as far as banks are concerned. So, a bit of social comment there. So we're going to make a method called allowed. And allowed basically has two parameters. It has how old you are and how much money you bring in every year. And the business rules that I've got for this bank is different from the one in the lab, by the way, and that's intentional, just to get you to not quite block copy the code. We've got, if your income is bigger than or equal to £10,000 a year, and your age is bigger than 18, or bigger than or equal to 18, you can have a bank account, else you can't. Okay? Does that make sense? So that's the business logic. That lives inside my class, and it determines whether or not we can have an account, correct? So when I construct the account, I have to tell it the name, and the age, and the income of the person I'm making the account for. And if I give it those three bits of data, if the age is too low, or the income is too low, in other words, if this thing returns false, we throw an exception and blow up. Because we're nice like that, okay? So this guy does the job of, it's like a bouncer really. If you can't come into my club unless you've got these particular, unless you're not, no trainers and all that kind of stuff. Income's bigger than 10,000 we like, age is bigger than 18 we like. But the snag is that at the moment, we can't use this method until we have an account, which that's a bit stupid. I only call that method when I already have an account instance. So that means that I might get exceptions and things being thrown, and I'd really rather be able to check first. Now, there's no way the outside world can guess whether an account's allowed or not. It has to call that method to find out. So what I do is I make the method static. Now this means I don't need an account to actually call the method and test whether or not the account is allowed. Does that make sense? My situation is I want to ask something to find out if this age and this income means I can make an account. I can't ask an account because I haven't made one yet. It's a chicken and egg situation kind of thing. So what I want to do now is have a method which I can call that just basically says yeah or no, but it doesn't form part of any account instance. So I make it static. Let's go back to the code. And what we'll do is we'll open up recent solutions. Who should we have? I have no idea. That one might work. Yeah, save all that. I'll put that up on, well, we'll come back in a minute anyway. So here's withdraw funds, here's all my stuff. That's the breakpoint we just saw. Go into the account class. Not you, you. So in here, I go, I use block copy. I quite like block copy. sometimes. Right, so grab hold of this guy, cut that code, go back here and paste it in. Oh, right, that's lovely. Right, so I've got a method called static, called allowed, sorry. And I can write code to check whether or not a particular bank account is allowed now. And so I can call this any time I want to find out whether or not a particular account income and age pair are available to be used. I'm in the middle of my Windows Forms environment, which is a bit annoying. But what I could do is I could do something sneaky. So what we'll do is we'll go into here and we'll just put some code in on the demo editor. I'll go if account.allowed 50, that's his income. 50 is not enough, and an age of 12 is not. That's basically a paper round we're talking about here. Then, so that if that returns true, that means I can make an account, correct? Now, interesting things to note about accounts and stuff like that. Message box.show hey, exclamation mark. Am I ever gonna see hey? He's getting 50 quid a year and he's 12 years old. I think not. Okay, let's turn him into Rupert Murdoch. Close enough. Yeah, more social comment. Will that display hey? Let's put the breakpoint in and step through. Hit the breakpoint. So we've got stepping into the method now. I love doing this. Boink. Income is 50 grand. Age is 120. So I'm going to chug through now. Step into. Doink. Turn true. And so up comes hey. And there it is. So then my program starts as normal. So interesting things about static methods. I'll be in the slides, I'll mention them now. Because you don't have an instance to call the method on, you call it on the class. So I don't say rob.allowed or account number 35.allowed. I say account because it's stored for the account, not for any particular instance. So this guy here, he's always there. You can use him anytime you like. And if you call him, he'll basically just run on that class. Another use for static, which you may have already seen, I can do things like this if I want, although I wouldn't do, but I could do. Income equals math, capital M, Rob, math.abs. Income. Now what do you think that does? It has nothing at all to do with muscles. Math.abs? No. Okay. Working out a six-pack using math.abs? No. Okay, shall I move on? Yes. Right, okay, so abs means absolute. Okay? And math is a whole ton of math methods which are provided for use by the programmer. And I can do this trick. I can right-click on here and say go to definition. Hey, where are you? And look, he's a public static decimal method that accepts a decimal value and returns a positive value of that. So if we feed it minus whatever, we get a positive one back. Abs says take the absolute value. If it's positive, it comes back. If it's negative, it changes the sign and brings it back. It gives you the absolute value. Does that make sense? I've also got, here you go, I've got double version, a float version, an int version, a short version, and I've got signs, I've got cos, I've got logs, I've got whatnot. Now, these are all methods that everybody wants, but nobody wants to have to make a class to get hold of them. So the math class is static, which means we're never going to make one of these guys. It's already there, and it contains nothing but static members. So here you go, there's pi. 3.1415, yeah. I use may have a large container of coffee, which is pi to 9 decimal places. May has got 3 letters, I has got 1 letter, have has got 4, and so it goes on. May I have a large container? That kind of works. Except you're sitting in the exam going, I'd like a Starbucks. That doesn't work. Boom. So, yeah. These guys are all static because they're part of the math class and everyone wants to use them. So, good place to look for doing sums. There's all kind of max, min, round, sine, squirt, tan, truncate, all kinds of good stuff there. So, here's the thing. Why wouldn't I do that? What does it do? Time to get profound. What does it do? It makes sure that the income value is always positive. So if I type in aloud minus 5,000, that'll make it plus 5,000 to make my test work properly. Is that a good thing to do? No. They might actually be losing money. And I don't want that to I don't want to be hiding errors. I want this thing to blow up if they give me errors, so I wouldn't do that. But it's a good use of static, which is kind of where I came in. And if this has got you thinking of sensible, oh no. Yeah. If you're thinking, okay, this means it's a way I can build into my class behaviours that are always there and I can use at any time, then I'm starting to quite like that as a concept. Does that make sense? So anything which your class has to do without needing to have an instance around, then I like that. So that's kind of the context in which you use these things. And like I said on the thing, if you want to call this thing, you call it against the class, not an instance. This is new. Haven't seen this before. This is a bit of newfangled stuff. And so the method's called from the class, not from a particular instance of the class, because it's always there. We don't need an instance now. Okay? So, like I also said, the math class provides a ton of static methods we can use to provide utility behaviours. And if you ever want to provide a behaviour without the object wrapped around it, you should use a static method. Okay? So, there you go. I don't particularly like this code for 2 reasons. 10,000 and 18. There's 2 reasons why I hate those numbers. Anyone know what those reasons are?
They're not magic numbers.
They're not magic. They're not being managed as magic numbers. They're being managed as, 10,000 and 18. So when the bank manager comes back to you and says, we'd like to change the minimum age to 17, please, for legal reasons, you have to go and do a search and replace on your code and find all the 18s and change them into 17. This will end very badly, in my experience. What you want to do is change one thing in one place once and then pocket a huge fee from the customer. So I'd like to have variables that represent those values, and so I want to have this. I want to go, if the income is bigger than or equal to minimum income and the age is bigger than or equal to minimum age, then do your stuff. Now, I've got 2 new variables just appeared, min income and min age. I can make a couple of values that hold variables to hold those things. What do we know about these 2 variables that's really, really, really important? What must they be? Constant? Yeah, maybe. What else must they be? Begins with st and ends with attic. Static, thank you. He's read the script. Fantastic. They've got to be part of the account. They can't be part of an instance. So they have to be static as well, because static methods can only ever touch things that are going to be around as well. I've just thought of a... See if this works, okay? You lot come and go. Every 3 years I got a new crop of students, okay? But the members of staff are always here. So I guess that makes us the ones that are static. I'm not sure. That probably doesn't work, actually. But keep that one in mind. If you keep going back to the planet Jupiter, you'll be fine. If I can make a link in your heads between static and planet Jupiter, then you can get there from radio things and always present and whatnot. So just hold that one. That might work. But if you go back to intent, we have to make these two guys static. So min age and min income live inside the class, and they're both static values because they're going to be used by methods that are always there, so they have to be always there as well. Okay? So, yep. We've always been able to use the main method because of the fact it's static. If you take that away, the compiler says, quite literally, I don't know where to start with this program. There is no main method. The method has to exist before we've made any objects. And in fact, for the first month or so of our programming career, maybe longer, we didn't do anything other than run code inside this static method. Then we branched out and put some member variables in the class, and off we went with other things as well. So, yep. Other things, other good uses for static are things you want to have set for the entire class of objects, like perhaps, say, the interest rate. I may want to have the interest rate set once for everybody and then change it and not have to spin through all the classes and change that particular property. So I can make the interest rate a static member and set it to whatever, and then I can change that as and when required. So as far as we're concerned, the key kicker, the key takeaway from this is static means it's always there. It does not mean it can't be changed. I can make things impossible to change. They're called const in C#, but they're not what I'm doing here. What I'm doing here is much more fundamental. Whenever you have a business object, like an account, or a toothbrush, or a chicken, or whatever, there'll be business rules associated with that. And you'll have those business rules inform the behavior of your methods. And you want to test those business rules before you have an instance of that object. And that means you're saying a big hello to Mr. Static, because those are the methods and objects and values that you'll use to do that testing. And I reckon that's pretty much it. Before I go there, any questions on this? If you get into trouble with static, think very hard about the business problem it's solving. I want to do something before I have an object to do it with, or without an object, and you'll be fine. Okay, thank you for that. See you tomorrow.